Computer networking. Learning objectives. Understand computer networks. Identify network components. Recognize network types. Comprehend network topologies. Learn network protocols. In our daily lives, we often connect with friends, family, and even strangers through various means of communication. We use phones, letters, emails, and social media platforms to share information and stay connected. A network is a collection of interconnected devices that communicate and share resources, similar to how you may have a television or cable network in your home. Computer networks allow devices to communicate and collaborate. Computer network. A. Computer network is a collection of interconnected computers and other devices that communicate with each other to share resources, information, and data. These networks enable users to exchange files, access shared software applications, and utilize common hardware such as printers and scanners efficiently. In a computer network, devices are connected through various means like wires, cables, optical fibers, or wireless signals. The primary purpose of establishing a network is to facilitate seamless communication and resource sharing among multiple users, which enhances productivity and reduces costs. Networks can vary in size and scope. A simple network might connect two computers, while a complex network like the Internet spans the globe. Devices within a network can be connected using cables, telephone lines, radio waves, or satellites. Advantages of computer networks. Computer networks offer several advantages. Networks allow multiple users to share hardware devices like printers and storage devices, thereby reducing the need for individual peripherals. Users can easily share and access data and information across the network, promoting collaboration and efficient workflow. Networks provide various communication platforms such as emails and instant messaging, enabling quick and effective interaction among users. Sharing resources and data over a network reduces the overall operational costs by minimizing the need for duplicate equipment and software licenses. Networks allow for centralized control and management of data and resources, making it easier to monitor and maintain the system. Did you know? The first ever computer network was the ARPANET, developed in the late 1960s, which eventually evolved into what we know today as the Internet. Components of a computer network. A computer network consists of several essential components that work together to enable communication and resource sharing. The primary components are as follows. Sender. A computer that initiates the communication by sending data to another computer on the network. Receiver. A computer that receives the data sent by the sender. Transmission medium. The physical or wireless pathway through which data is transmitted from the sender to the receiver. Message. The information or data that is transmitted from one computer to another. Protocol. A set of rules and conventions that govern how data is transmitted and received over a network. Network terminology. To understand how a computer network functions, let's explore its key components. 1. Node. A node refers to any device connected to a network. This can include computers, printers, routers, switches, and any other devices that can send, receive, or forward data within the network. Server. A server is a powerful computer or software that provides resources, data, services, or programs to other devices known as clients in the network. Servers manage network resources and respond to requests from client devices. 3. Client. A client is a device or program that requests services or resources from a server in a network. For instance, when you access a website, your computer client sends a request to the web server to display the web page. 4. Protocol. A protocol is a set of rules and conventions that determine how data is transmitted and received over a network. Common protocols include TCP/IP, Transmission Control Protocol/Internet Protocol, which governs data communication on the Internet. 5. IP address. An IP address, Internet Protocol address, is a unique numerical label assigned to each device on a network. It serves two main functions: identifying the host or network interface and providing the location of the device in the network. MAC address. A MAC address, Media Access Control Address, is a unique identifier assigned to the network interface card in IC of a device. It is a hardware address that helps in identifying devices at the data link layer of the network. 7. Bandwidth. Bandwidth refers to the maximum amount of data that can be transmitted over a network in a given amount of time. It is usually measured in bits per second (bps) and affects the speed and efficiency of data transfer in a network. Components required for a network. To set up a computer network, various hardware and software components are required to ensure efficient communication, data sharing, and resource management. These components work together to create a robust network infrastructure. Network Interface Card in NETI. A network interface card in NETI is a hardware component that allows a computer or device to connect to a network. NETIs can be wired or wireless depending on the type of network connection. Each NETI has a unique MAC address, which is used to identify the device on the network. Every computer must have an NETI to connect to the network. It is typically installed inside the computer and has a port where the network cable is plugged in. Cables and connectors. Cables are the physical mediums that carry data between devices in a wired network. Common types of cables include twisted pair cable, consists of pair of wires twisted together to reduce electromagnetic interference. Coaxial cable, a single copper wire surrounded by insulation and shielding to reduce interference. Fiber optic cable transmits data as light pulses through thin glass fibers, offering high-speed data transmission and resistance to interference. Connectors like RJ45 connectors are used to attach the cables to devices and network equipment. Switch. A switch is a networking device that connects multiple devices within the same network, such as computers, printers, and servers. It receives data from a source device and forwards it to the correct destination device within the network, based on MAC addresses. Hub. A hub is a basic networking device that connects multiple devices in a network, allowing them to communicate with each other. Unlike a switch, a hub broadcasts data to all connected devices, which can lead to network congestion and is less efficient for larger networks. Router. A router is a device that connects different networks, directing data between them based on IP addresses. Routers are essential for connecting a local network LAN to a larger network, such as the Internet. Modem. A modem modulator-demodulator is a device that converts digital signals from a computer into analog signals for transmission over telephone lines or cable systems and vice versa. Modems are necessary for connecting to the Internet via traditional telephone lines, DSL or cable. Access point. An access point (EP) is a device that allows wireless devices to connect to a wired network using Wi-Fi. Access points are commonly used in wireless local area networks, WLANs, to extend the network's reach and provide wireless connectivity in large or open areas. Types of networks. Computer networks can be classified based on their size, scope, and purpose. The main types are: types of computer networks: TAN, Personal Area Network; LAN, Local Area Network; MAN, Metropolitan Area Network; WAN, Wide Area Network; CAN, Campus Area Network. Personal Area Network, TAN. A personal area network, PAN, is a small network designed for personal use, typically within a range of a few meters. PANs connect personal devices such as smartphones, tablets, laptops, and wearables. PANs can be wired using USB cables or wireless using Bluetooth or Wi-Fi. They are ideal for connecting devices for personal use, such as syncing data between a smartphone and a laptop. Local Area Network, LAN. A local area network, LAN, is a network that connects computers and devices within a limited geographical area such as a home, school, or office building. LANs are typically used for sharing resources like files, printers, and internet connections among a small group of users. They offer high-speed data transfer rates and are usually managed by a single organization or individual. Wide Area Network, WAN. A wide area network, WAN, spans a large geographical area, often covering cities, countries, or even continents. WANs connect multiple LANs, allowing users in different locations to communicate and share resources. The Internet is the most common example of a WAN. WANs typically require routers and other networking technologies to manage data transfer across long distances. Metropolitan Area Network, MAN. A metropolitan area network, MAN, is a network that spans a city or a large campus, connecting multiple LANs within the area. MANs are larger than LANs but smaller than WANs, providing high-speed connectivity over a broader area than a LAN. They are often used by organizations with multiple buildings within the same city or by service providers offering high-speed internet services to residential customers. Campus Area Network, CAN. A campus area network, CAN, is a network that connects multiple LANs within a limited geographical area such as a university, industrial complex, or military base. CANs are larger than LANs but smaller than MANs, providing high-speed connectivity across the campus. They often include buildings such as offices, classrooms, libraries, and residential areas. Network topologies. Network topology refers to the arrangement or layout of different devices, nodes, in a network. It describes how these nodes are interconnected and how data is transmitted across the network. The common types of network topologies are Bus topology. All devices nodes are connected to a single central cable known as the bus. Data sent by any device travels along the bus and can be received by all other devices connected to the network. However, only the intended recipient accepts and processes the data. Characteristics: requires minimal cable compared to other topologies, less cabling and no need for additional network devices like switches or hubs. Difficult to add new devices without disrupting the network. If the central bus fails, the entire network goes down. Example: older Ethernet networks often used bus topology. Star topology. In a star topology, all devices are connected to a central device, typically a switch or hub. Each device has its own dedicated connection to the central device, and data sent by one device is transmitted through the central hub to the target device. Characteristics: if one connection fails, the rest of the network remains unaffected. Simple to add or remove devices without disrupting the network. The central device manages and directs all data traffic. Requires more cabling and a central device, which can increase costs. Example: most modern Ethernet networks use star topology with devices connected to a central switch. Ring topology. In a ring topology, each device is connected to two other devices, forming a circular path for data transmission. Data travels in one direction or unidirectional or both directions bidirectional around the ring until it reaches its destination. Characteristics: data moves in a specific direction around the ring. If one device fails, it can break the network, but some ring networks can reroute data in the opposite direction. Each data packet must pass through multiple devices before reaching its destination. Identifying and fixing network issues can be complex. Example: token ring networks developed by IBM used ring topology. Mesh topology. In a mesh topology, every device is connected to every other device in the network. This creates multiple paths for data to travel, ensuring that if one path fails, another can be used to maintain communication. Characteristics: multiple paths between devices prevent network downtime. Requires significant cabling and network interfaces. Can easily accommodate additional devices, though at increased cost and complexity. Data can take the shortest path to its destination, improving performance. Example: used in critical network environments such as military communications and financial networks. Tree topology. A tree topology combines characteristics of both bus and star topologies. It consists of groups of star-configured networks connected to a central bus. Devices are arranged in a hierarchical structure with the central node at the top. Characteristics: hierarchical structure simplifies management by grouping devices, easier to add new devices to different branches. Requires careful planning to avoid data collisions and bottlenecks. If the central bus fails, the entire network can be affected. Example: large organizations with multiple departments may use tree topology to segment and manage their network. Hybrid topology. A hybrid topology is a combination of two or more different types of topologies. For example, a network might use a star-bus hybrid where several star-configured networks are connected using a central bus. Characteristics can be tailored to meet specific network requirements. Managing and troubleshooting a hybrid network can be more challenging. Can balance cost and performance by combining the strengths of different topologies. Offers a versatile approach to network expansion. Example, a corporate network that uses star topology for departments and connects them via networking architecture. Networking architecture refers to the design and structure of a network, including how data is transmitted, managed, and secured within the network. It involves a combination of hardware, software, protocols, and services to ensure efficient communication between devices. There are two primary types of networking architecture: client-server architecture and peer-to-peer network. Client-server architecture. In a client-server architecture, the network is divided into two main entities, clients and servers. The server is a powerful computer or software application that provides resources, data, or services to clients. Clients are devices or software applications that request services or resources from the server. Example, a company network where employees' computers, clients access files and applications hosted on a central server. Peer-to-peer P2P architecture. In a peer-to-peer architecture, all devices, peers in the network, have equal status and can act as both clients and servers. Each peer can share resources, such as files or printers, directly with other peers without relying on a central server. Example, a small office network where each computer shares files directly with others without a central server. Wireless networking technology. Wireless networking technology allows devices to communicate and share data without the need for physical cables. This technology has revolutionized the way we connect devices, offering greater flexibility, mobility, and convenience. Wireless networks are essential in various environments, including homes, offices, and public spaces. Wi-Fi, wireless fidelity. Wi-Fi is a widely used wireless networking technology that allows devices like laptops, smartphones, and tablets to connect to the Internet or a local network without the need for physical cables. It operates on the IEEE 800 and 2.11 standards and typically covers a range of up to 100 meters indoors and 300 meters outdoors, depending on the environment. Wi-Fi is commonly used in homes, offices, and public hotspots for Internet connectivity and local networking. Bluetooth. Bluetooth is a short-range wireless technology designed for connecting devices within close proximity, typically within a range of about 10 meters. It is widely used for pairing peripherals such as wireless keyboards, mouse, headphones, and for data transfer between mobile devices. Bluetooth operates on the 2.4 GHz ISM band, using frequency hopping to minimize interference with other wireless devices. It is known for its low power consumption, making it ideal for battery-operated. Tidbit: the term hotspot refers to a specific area where Wi-Fi access is available, often in public places such as cafes, airports, and libraries. No more. 5G networks are the latest generation of mobile networks, offering faster data transfer speeds, lower latency, and the ability to connect more devices simultaneously. They are expected to revolutionize the way devices communicate over wireless network. Protocols in networking. Protocols in networking are a set of rules and conventions that determine how data is transmitted, received, and processed across a network. These protocols ensure that devices with different hardware and software configurations can communicate effectively, providing a common language for network communication. Here are some of the most important protocols used in networking. Transmission Control Protocol (TCP). TCP ensures reliable, ordered, and error-checked delivery of data between devices on a network. It breaks down data into packets, sends them individually, and reassembles them at the destination, making it ideal for applications like web browsing and email. Internet Protocol (IP) is responsible for addressing and routing packets of data to ensure they reach the correct destination across networks. Hypertext Transfer Protocol (HTTP). HTTP is used for transmitting web pages over the Internet. It operates on top of TCP/IP and allows web browsers and servers to communicate. HTTPS is the secure version that encrypts data. File Transfer Protocol (FTP) is used for transferring files between computers on a network. It allows users to upload, download, and manage files on a remote server, commonly used in website management. Simple Mail Transfer Protocol (SMTP) is the protocol used for sending emails across the Internet, ensuring that messages are delivered from the sender's email client to the recipient's mail server. Dynamic Host Configuration Protocol DHCP automatically assigns IP addresses and network configuration parameters to devices on a network, simplifying the connection process and ensuring each device has a unique IP address. Secure Shell SSH provides secure remote access and management of devices over a network, encrypting the data to protect against unauthorized access. Internet Message Access Protocol IMAP allows you to access and manage emails directly on the server, making it possible to view emails from multiple devices and keep them synchronized. Post Office Protocol version 3, POP3. POP3 downloads emails from the server to your device and usually deletes them from the server, meaning emails are stored locally and are not synced across multiple devices. Fact, the DNS protocol is often referred to as the phone book of the Internet, as it translates domain names into IP addresses, enabling users to access websites without needing to remember complex numerical addresses. Chapter Essentials. A computer network enables communication and resource sharing among interconnected devices. Key components include nodes, servers, clients, protocols, IP addresses, MAC addresses, and bandwidth. Common network types include PN, LAN, MAN, WAN, and CAN. Network topologies such as bus, star, ring, mesh, tree, and hybrid define the arrangement of devices. Client-server and peer-to-peer architectures represent different network structures. Wireless technologies like Wi-Fi and Bluetooth offer cable-free connectivity. Protocols like TCP/IP, HTTP, FTP, SMTP, and DHTP govern data transmission and management.